Hello, my name is Javier Ayala.
And Williams.
I'm Yahya Rashid.
I'm Nicolas Ovalle.
And this is Engineering 1331, summer of 2018. Our NAE project is based on urban infrastructure. We are concentrating on the statistics of traffic occurrences throughout the city of Houston. We used the data provided by the City of Houston's Public Works and Engineering Department to view the data of specific intersections and create codes that would view the areas of risks of heavy congestion. A statement from the United States Census states that between 2010 and 2017, the city of Houston has seen a 10% increase in our population. And as the old saying goes, the more population, the more transportation need required to transport the population, and hence there's going to be more traffic on the streets. Houston needs a new system that could track these traffic patterns that occur with this increasing population, and hence our code provides a new method of measuring and comparing traffic data for specific intersections between years to spot areas of risk of severe congestion, so the city of Houston officials can see which areas they would need to concentrate and improve to go along with this increasing population.
Our code began just like any other code does, with the housekeeping commands. After that, we loaded in our CSV file, and this was tricky because the CSV read would not work since our data had many blank spots in it. So we had to use the read table command. After that, we created our text file, which basically will send all of our outputs in a separate text file at the end. And then we extracted all of our data that we needed from the table, which was our names of the street, the ADT, which is the average daily traffic of that particular street. We extracted the percentile speed 85, which was the speed that 85% of the traffic is following, and we extracted the years. From then, we needed to do a table to array so that we could work with all of our vectors. And then we needed to figure out where the average speed was greater than 0, where the ADT was greater than 0, which means that data was collected for that particular street. So we found all of the streets which had data on it. This was the data which we indexed for the rest of the project. We also made a whole new variable called congestion. We found this variable by dividing the average daily traffic by the percentile speed 85. This variable shows how traffic filled each street is. After this, we found the minimum and maximum of congestion of our traffic and our percentile speed 85. And what we did is we used the find command to index which rows they were stored in so that we could later index these rows to our names so that we could find the particular street name which had the highest or lowest congestion ADT or percentile speed 85. We then created a menu which allowed the user to select if they wanted to see the highest ADT, the lowest ADT, the highest percentile 85, the lowest percentile 85, the highest congestion, or the lowest congestion. So once the user clicks an option from the menu, we displayed the highest or lowest value of that respected category and the street name in which the highest and lowest can be found. We allowed the user to click as many options they wanted to see outputted from the menu.
Okay, so the code now asks, would you like to examine a specific street, yes or no? Hopefully, deciding you select yes, it's going to ask you to input the first letter of a street. Now, the reason we do this is because we have a giant vector of over 1,500 names or something like that. So we can't just make a big giant menu of 1,500 names because it's not going to work. So we ask you to enter the first letter of your street. That way we can minimize the amount of street names. However, even with one letter, you're still going to have hundreds of names. So after we ask you for the first letter, we ask you for a second, and then we're actually going to ask you for a third. That way we can get our menu as short as possible without, overloading the menu screen. But by doing this, we had to make sure we uppercase whatever input the user inputs inside, because all the name vectors are all capital. So what we do is we have you input a letter, we uppercase it, then we search through, then we started another if statement for the second letter, did the same thing, made another if statement for the third letter. After that, we have our menu screen of the possible street names that you could select, and once you select the street, it's going to give you the output. It's going to give you an fprint statement, which outputs the ADT, the percentile speed, and the calculated congestion for that specific street. And then what we came up with is we have a figure that presents 3 bar graphs. The first bar graph is going to be your average ADT versus the selected street. Then you're going to have your average congestion versus your selected street, and then your average percentile speed versus the selected street. Then after that, we have the while loop to come to a complete by asking you if you want to select another street. If you want to select another one, it's going to rerun it, and it's going to bring you back through to select whatever street you want. You can get the news data, and you can keep running this over and over and over again to your liking.
The importance of this code is for a user to be able to go and use our code and to output different data of different parts of the city, as well as generalized data of the city, and use this as a way to present the information about our city's traffic, and use that to find how we will improve the urban infrastructure of our city, specifically when it comes to traffic. For that reason, we have created as part of our outputs a TXT file. We do so by, at the beginning of the code, asking the user to type in a string. Once they type in the string, it's stored in a variable, and that variable, using sprintf, it has a .txt added after it, just to make sure that it's written correctly. Then we use fopen to open up a txt file using that string name, and every single time the user selects, for example, in the first menu, a general information, as well as that line being printed into their command window, it's also written into their TXT file. And at the beginning of their general information, a general information line is printed as well. And then later on, a one for specific streets is also printed, just so that the user has this information organized in a way that they can use this TXT file later to present. So for example, a user goes in and they input a file name for just South Houston, and then they just select streets in South Houston, and at the end of running the code, they'll have all this information with their street information that they can use to present and use to further the city's infrastructure. The one thing that's not written to the TXT file are the graphs. So the user will not be able to see the graphs again, but every single one of the lines that is output into the command window can also be seen on the TXT file.
In conclusion, we believe the implication of these systems could provide a new and improved method of analyzing and comparing data that could aid on road construction and different projects around the city of Houston, and on other cities if this is implemented over there as well. We hope that you love our project, and that will be a great help into future endeavors on urban infrastructure and development. Thank you.